So hello everyone. In this demo, we'll be walking through Shardo, which is basically a non-custodial Solana wallet, which under the hood uses a TSS, which is a multi-party computation scheme for transaction signing. And let's just get started, and we'll talk about the architecture later. So let us sign in. So I have signed up for this username already, and I'm just gonna put in the password. So after signing in, as you can see, we have a user's public key is shown here, which is basically aggregated from two different public key components, which have been made separately in the two MCP servers. So basically, we fetch those two public keys and aggregate them to make a uh, deterministically aggregate them to basically make a new public key for the user. And for the convenience of this demo, I have already airdropped some Sol in it because sometimes it's unpredictable whether we will be able to airdrop ourselves because of the rate limit. And yeah, obviously you can also go over to this endpoint and airdrop yourself some Solana like this. But for this demo, we have already done that. So let us just send some Sol to some other wallet. Let's say, let me just log into my Phantom wallet, and as you can see, this is some other recipient uh, address that I'm entering, and this particular address has already 20.8 souls. So let us send, let's say, 0.5 souls to it. So we'll just hit send soul and wait a bit. Okay, so as you can see, we have a transaction sent successfully pop up over here. So if you can refresh right now, it will say we have a 0.5 sent to this particular address and some fees obviously. And if you go and see this wallet, as you can see, the transaction is also reflected over here. So this is basically the working demo. So basically what happens under the hood is when a user signs up, the username and password goes to the main wallet backend where it is being being stored in a database, and then the backend also initiates basically forming a key pair, two separate key pairs in two different MPC servers over here, and they store it in their respective databases. So when a user comes in and sends a transaction, so basically user comes in and gives information like recipient and amount to the wallet backend. That same information is then conveyed through authenticated endpoints to the two different MPC servers. They fetch the key pair for that particular user and then use MPC schemas to basically interchange public messages, and then send independently send partially signed transaction for the given transaction. And in the main wallet backend, then what we do is basically combine these two partially signed transaction, and then we basically broadcast it to a remote RPC. So and that's how basically the flow of the whole wallet works. And yeah, so that's pretty much it. Under the hood, it basically uses Zengo's Solana TSS CLI backend, Rust CLI, and yeah, that was pretty much it. Thank you.